days to all of you. Today, I'm going to show you some concepts and questions about the Form 4 Chapter 6 Linear Law. In this chapter, we will learn that a linear graph is a straight line graph which has a linear equation y equal mx plus c. Here m represents the gradient of the graph and c represents the y-intercept. A graph which is not a straight line does not have a linear equation. So a line of base fit that can be drawn based on the linear equation y equal mx plus c. So let's look at the characteristic of a base fit line. The characteristics of a base fit line are: 1. The line must pass through as many points as possible. 2. The points that are not lie on the line of base fit has uniform distribution on the left or right of the line and has almost equal distance from the line. So now look at the sample questions in paper 1. Here, the diagram shows part of the straight line graph of the equation y equals to a plus b over x. The question is, find the values of a and b. So now let's look at the graph provided. Here the y-axis represent xy and x-axis represent x. So let's look at some solution. At first, we must express equation in linear form, that is y equals to mx plus c. From the question, we can see that given y equals to a plus b over x. So, by multiplying both sides with variable x, we will get the linear equation xy equals to ax plus b. So from this linear equation, we can see that a represents the gradient of the graph. By using the points given from the straight line, substitute them into the formula of gradient, that is y2 minus y1 over s2 minus s1. So we will find that 9 minus 0 over 5 minus 2. So the value of constant A is 3. How to find the value of constant B? By substituting the point 2, 0 into the linear equation xy equals to ax plus b. Bear in mind that 2 represents x and 0 represents xy. So we will find that 0 equals to 3 times 2 plus b. So the value of constant b is negative 6. Now let's look at the question number 2. In this question, diagram shows part of the straight line graph of log y against log x. Variable x and y are related by the equation y equals to ax to the power of n. Question number A. Find the values of a and n. So please look at the variable on y-axis, that is log y, and the variable on x-axis is log x. So let's look at the solution. As usual, we still have to form the linear equation first. By putting the log on both sides of the equation, we will get the linear equation, that is log y equals to n log x plus log a. From this linear equation, we can see that the constant n represents the gradient of the graph. By using the points provided in the graph and substitute into the formula of the gradient, we will find that 4 minus 0 over 0 minus negative 3. So the value of constant n is 4 over 3. So now let's look at the y-intercept. From the equation, y-intercept is log y, and from the graph, y-intercept is 4. So by comparing the log y to 4, then we will find that the value of a is 10,000. Now let's continue with question number B. Find the value of y when x equals to 1000. Let's look at the solution. From A, we find that the linear equation is log y equals to 4 over 3 log x plus 4. So when the value of x is 1000, we substitute the value of x into the log x, that is log y equals to 4 over 3 log 1000 plus 4. Here the value of log 1000 is 3. So the value of log y is equals to 8. Then by anti-log the value of 8, then we will find that the value of y is 10 to the power of 8. Now let's continue with the sample questions in paper 2. In this question number 1, the variable x and y are related by an equation y equals to ax squared plus bx, where the value of a and b are constant. Question number 8. Draw the graph of y over x against x. Okay, so let's look at the solution. Here, even though the question does not ask to build the table, but we still have to build the table before draw the graph. So the value of y over x must be built. There are 7, 8, 6, 4, 2, 0, and negative 2. And by using the value of x provided and the value of y over x, a graph can be plotted. In this graph, we must make sure that the uniform scale is using, and and then the points are plotted correctly. And finally, make sure the line of best fit is drawn. In this graph, the line of best fit can pass through as many points as possible, and there is only one point is not passing through by the graph. So this is the line of best fit. Okay, now from your graph, find 1. The value of y which is wrongly recorded and state the correct value. So let's look at the solution. By referring to the graph, there is a point which is far from the line. So this is the wrong point. So from the graph, the wrongly recorded value y over x is 7. So here is 7. And the corresponding value x is 1. So we can see that the wrongly recorded y equals to 7. By moving the wrong point to the line, so from the graph we will find that the actual value y over x is 9. By substituting the value of x equals to 1, so y over 1 equals to 9. So the actual value of y is 9. Look at the question B2. Find the values of a and b. So this is the solution. From the question, given that y equals to ax squared plus bx. So a graph of y over x against x is plotted. So we must form the linear equation, that is, by dividing the both sides with the variable x. Then the linear equation is y over x equals to ax plus b. From the equation, we can see that constant a represents the gradient of the graph. So by choosing any 2 points from the graph, for example, here the point 2x and x2 are chosen. So by substituting the point into the formula of the gradient, that is y2 minus y1 over x2 minus x1, so the value of constant a is -1. And then to find the value of constant b, which represent the y over x intercept, we can refer to the graph. From this graph, the y-intercept is 10. So the value of b is equals to 10. Now let's look at question number 2. Table shows the values of 2 variables x and y of an experiment. Both x and y are related by the equation y equals to mx plus n square root x. Question number 8. Construct a table for the values of y over square root x and square root x. So the table with the value of square root x and y over square root x is plotted. Is constructed here, sorry. Okay. And for the question number B, plot y over square root x against square root x by using a scale of 2 cm to 1 unit on the square root axis and 2 cm to 5 units of the y over square root x axis. Hence, draw the line of best fit. So let's look at the solution. This is the graph drawn where we must make sure that the uniform scale is used in the graph. In the second, we have to make sure that the points are plotted correctly. And finally, the line of best fit is drawn. Here we can see that there are 2 points which are not lines on the straight line. So make sure that one of the point is on the left of the line and another one is on the right of the line, so that the characteristic of the best fit line is fulfilled. Okay, now let's continue. Question number C, from the graph, find the value of m and of n. So the solution is here. Question provided that y equals to mx plus m square root x. So to form the linear equation, we divide both sides with the square root x. So the linear equation is y over square root x is equals to m square root x plus n. So from this equation, we will find that m represents the gradient of the graph. By referring to the graph, we choose any 2 points from the line. For example, we choose 6, 26 and the point 1, 6 and substitute the points into the formula of the gradient. So we will find that 26 minus 6 over 6 minus 1 is equals to 4. So that means the value of constant n is 4. Then now let's look at the constant n. From the equation, n represents the y-intercept. So by referring to the graph, the value of y-intercept is 2. So that means the value of n is equals to 2. Now let's continue with question number 3. The table shows some of the experimental values of variable x and y. The variable x and y are related by the equation y equals to h k to the power of x, where h and k are constants. Question number A. As usual, based on the table, construct a table for the values of log 1. So we just copy the value of x from the table and we find the value of log y. So these are the answers. Now let's look at question number B. Also, as usual, plot log y against x using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 0.2 unit on the y-axis. Hence, draw the line of best fit. So we use the scale given and we plot the points based on the table view and we draw a line of best fit. So also as usual, there are three aspects that we must consider when we are drawing a graph. That is, make sure the uniform scale is used and the points are plotted correctly, and finally the line of best fit is drawn on the graph. Let's look at question number C. Use a graph obtained. Find the value of x when y equals to 35. So bear in mind that we have to refer to the graph to obtain the correct answer. Let's look at the solution. So when value of y equals to 35, so log y is equals to log 35. Then from the calculator, we will find that the value of log 35 is equals to 1.544. So by referring to the graph, the value of 1.544, and then we move down to find the value of x. From the graph, the value of x is equals to 2.4. Now let's look at the question C2. Find the value of k. This is the solution. Given that y equals to hk to the power of x, so the linear form of the graph is we must put the both sides with the log. Then we will find that log y equals to x log k plus log h. From the linear equation, we can see that log k represents the gradient of the graph. Also, as usual, by choosing any 2 points from the line. For example, here is 0, 1.73 and 6, 1.28. So substitute the points into the formulas of gradient. So we'll find that 1.73 minus 1.28 over 0 minus 6. So the value of log k is equals to negative 0.075. So by finding the anti-log, the value of k is equals to 10 to the power of negative 0.075. So the value of k is equals to 0.8414. How about the value of constant h? So from the linear equation that we found, log h represents the y-intercept of the graph. And by referring to the graph, y-intercept is equals to 1.73. So that means log h is equals to 1.73. By finding the anti-log, so the value of h is equals to 10 to the power of 1.73. So the answer is 53.70. So this is the value of the constant h. So until here, we can see that the process in solving the problem of linear law is almost the same. That is, we must form the linear equation. After that, we find the value of gradient and find the value of y-intercept. Let's look at one more question. That is question number 4. The following table shows some of the experiment values of two variables x and y. A. Plot a graph of 1 over y against x plus 1 and draw a line of best fit using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 2 units on the y-axis. So as usual, even though the question does not ask us to build the table, but we still have to build the table according to the variable on the x-axis and y-axis. They are x plus 1 and 1 over y. So now let's look at the graph plotted. So the graph is plotted based on the value in the table. So when we are plotting the graph, make sure that the uniform scale is used. And then the second one, the points are plotted correctly. And then the third one, a line of best fit is drawn on the graph. So in this version, the line of best fit can pass through all the points. And there's not even one point is cannot passing through by the line. Okay. So look at the question number B. Using the graph in A, so this is a graph plotted in A, find the value of y when x equals to 0.6. Let's look at the solution. When x equals to 0.6, x plus 1 equals to 1.6. Because here the variable on x-axis is x plus 1. So when x plus 1 is 1.6, okay, so the value of 1 over y is negative 1.8. Then the value of y is equals to negative 0.5556. For the question B2, find the gradient and the 1 over y intercept for the graph and hence express y in terms of x. So, question asks us to find the gradient. So from the graph, gradient is equals to 9 minus negative 5 over 7 minus 0, which is equals to 2. We just choose any 2 points from the line and then we substitute the points into the formula of the gradient. So the value of the gradient here is 2. And then how about the 1 over y intercept? By referring to the graph, the y-intercept here is -5. So we can form a linear equation by using the value of gradient and the value of 1 over y-intercept, which is found. So we will see that the linear equation is equals to 1 over y equals to 2 times x plus 1 minus 5. Then it will equals to 2x minus 3. So to express the y in terms of x, y is equals to 1 over 2x minus 3. Let's look at question number C. Calculate the value of y when x equals to 25. So the solution is like this. From B2, we found that y is equals to 1 over 2x minus 3. And when the value of x equals to 25, so y is equals to 1 over 2 times 25 minus 3. Then it is equals to 1 over 47. Or we also can express in decimal number, that is 0.02128. Let's look at the question number 5. In this question, table below shows the values of two related variables x and y obtained in an experiment, which are related by an equation y equals to h over x plus k over x squared, where h and k are constants. Question number A. Plot a graph of xy against 1 over x using a scale of 2 cm to 0.5 unit on the x-axis and 2 cm to 5 units on the y-axis, and hence draw a line of best fit. As usual, we still have to build the table before we draw the graph. So a table of which contain 1 over x and xy is built based on the value of xy provided. So the graph plotted is like this. So all the aspects of the line of best fit must follow. Here, make sure the uniform scale is used. The points are plotted correctly and a line of best fit is drawn. Now, let's look at question number B. From your graph, find the value of P when x equals to 1.2. Okay, so from the graph, when x equals to 1.2, so the value of 1 over x is equals to 0.83, because here the variable on x-axis is 1 over x. So when the value of 1 over x is equals to 0.83, from the graph, we will find that the value of xy is equals to 14.5. By substituting the value of x, that is 1.2, into xy, so we will find that 1.2y equals to 14.5. So the value of y is equals to 12.08. So that means the value of p is equals to 12.08. For question 2, find the value of Hn of k. Okay, from the equation, given that y equals to h over x plus k over x squared. So by multiplying both sides with the variable x, we will find that xy is equals to h plus k over x. Rearranging the equation, so we will get the linear equation, that is xy equals to k over x plus h. Once again, from the linear equation, we will find that the value of k is represent the gradient of the graph. By choosing any 2 points from the line, and we substitute the points into the formula of the gradient, we will find that 47.5 minus 5 over 3.5 minus 0 is equals to 12.14. That is the value of constant k. And from the equation again, we will find that the constant h represents the y-intercept. And from the graph, the xy-intercept is equals to 5. So that means the value of constant h is equals to 5. How about question number C? Find the value of x when y equals to 40 over x. Let's look at the solution. When y equals to 40 over x, that means xy is equals to 40. So here, the variable on the y-axis is xy. So when the value of xy is equals to 40, okay, we found that the value of 1 over x is equals to 2.9. So the value of x will equal to 1 over 2.9, that is equals to 0.3448.
Let's try some questions for the topic by using the QR code or link shown on the screen. You can discuss your answers with your teacher.
Our today's topic is coordinate geometry. In this video, I will not cover the whole topic, but mainly focus on first, the types of equation the locus, second, parallel lines and perpendicular lines. Let us first look at some important notes. Types of equation of locus. Now let's get into the details. Look at the following example. Let P be the moving point and A be the fixed point. Point P moves such that the distance from fixed point A is always r unit. We can see that the locus form is actually a circle. R is equal to AP, and the distance can be found by using the formula. B. Distance of the moving points from two fixed points are equal. Point P moves such that the distance from two fixed points A and B are equal. Then we say PA is equal to PB. The locus formed by the point P is actually a perpendicular bisector of AB. The ratio of the distance of a moving point from two fixed points is a constant. Point P moves such that the distance from point A and B is in the ratio of m to n. So we can rewrite this one in the fraction form. AP over BP is equal to m over n. Then we cross multiply this, we get NAP is equal to MBP. Now look at the knot of parallel lines. The diagram shows two parallel straight lines with the equation y equal to m1x plus c1 and y equal to m2x plus c2. Since the lines are parallel, they have equal gradients, that is m1 equal to m2. Now let us look at perpendicular lines. If two lines are perpendicular, then we say the product of the gradient of the lines is equal to -1. That is, m1 multiplied with m2 is equal to -1. Now let us look at some examples. Example 1. Point P and point Q are two fixed points. The point T moves in such a way that the ratio of PT to TQ is equal to 2 to 3. Find the equation of the locus of point T. We know that from the questions the T is a moving point. Therefore, we let point T be x and y. Now, the ratio of the PT to TQ is equal to 2 to 3. That means that PT is equal to 2, TQ is equal to 3. We cross multiply this, then we get 2TQ is equal to 3PT. Then we can use the distance formula to find the distance of TQ. We substitute the coordinates of x and y of point Q into the left hand side here. That is x equal to 0, y equal to -2. Whereas for the right hand side, we substitute in the coordinates of P. That is x equal to 2, y equal to 0 into the distance formula. Then we square both sides to eliminate the square root. So when you do so, please make sure that you square the number 2 here and also number 3 here. So when you square the number 2 here, you get 4. And you open out the y plus 2, you get y squared plus 4y plus 4. For the right hand side, you square number 3, you get 9. So you open out the x minus 2, you will get x squared minus 4x plus 4. Now, for left hand side, you multiply 4 with each term here. you will get 4x squared plus 4y squared plus 16y plus 16. And for the right hand side, you multiply 9 with each term. That is, you get 9x squared minus 36x plus 36 plus 9y squared. Then you try to group the like term together by shifting all the terms to the right hand side. So we shift 4x squared to the right hand side, we get 9x squared minus 4x squared, that is 5x squared. Then 4y squared and 9y squared, we get 5y squared. Now, negative 36x, since there is only 1, so we just copy it as negative 36x. And for this 16y, we shift it to the right hand side, will become negative 16y. And this number, 16 and 36, we will subtract it, we get 20 equal to 0. So the equation of the locus of t is 5x squared plus 5y squared minus 36x minus 16y plus 20 equal to 0. Now let us look at some student common mistake. When given the ratio, students always make mistake in this step. The correct way should be this. You have to cross multiply this and get the correct step here. Let's look at the example 2. A point Q moves in such a way that its distance from the point T is twice the distance from the point X. So from this sentence we know that Q is a moving point and we have QT is equal to 2QS. We can find the distance of QT by using the distance formula. Substitute the coordinate of T, that is X coordinate is equal to 2, Y coordinate is equal to negative 3 into the distance formula. And similarly to the right hand side, we substitute the coordinate of S, that is value of X value of 0 and Y values of 3 into the distance formula. Then we eliminate the square root by square the both sides. So for the left hand side, we have x minus 2 bracket square plus y plus 3 square. And for the right hand side, we square it. Please measure 2 here is square. You get 2 square is 4. So for the right hand side, we'll have this. Then we expand the x minus 2, we will have x squared minus 4x plus 4. We expand the y plus 3 square, we have y squared plus 6y plus 9. So for the right hand side, we expand it too. We expand the y minus 3, we have y squared minus 6y plus 9. Next, we multiply 4 with each term in the bracket here. We will have 4x squared plus 4y squared minus 24y plus 36. So rearrange it. Move all the terms in the left hand side to the right hand side. 4x squared subtract x squared, you get 3x squared. 4y squared subtract y squared, you will get 3y squared. And the negative 4x shift to the right, you get positive 4x. For the y, positive 6y shift to the right, you get negative 30y. And the number here, you will get 23. And there is one common mistake always done by the student here. This solution is not correct because the 2 here is not square. So when you eliminate the square root here, you make sure you don't forget to square the number. Next example, given the points A and B, find the equation of the locus of a moving point P such that the triangle APB always has a right angle at P. So we know that P is a moving point, so we let P be X and Y. And triangle APB always has a right angle at P. Therefore, AP is perpendicular to PB. Hence, the gradient of AP multiplied to the gradient of PB is equal to -1. We can use the gradient formula to find the gradient. That is 1 subtract y1 divided by s subtract s1. The gradient of AP is given by y subtract 1 divided by s subtract 0. The gradient of PB is given by y subtract 4 divided by s subtract 6. We can simplify it, then we get this. Y minus 1 multiplied with y minus 4 is equal to -x multiplied with s minus 6. Expand the left hand side, we have y squared minus 5y plus 4. The right hand side, we have -x squared plus 6x. We shift -x squared and also positive 6x to the left hand side, and we will have this x squared plus y squared minus 6x minus 5y plus 4 equal to 0. This is how we get the equation of the locus of the moving point P. Example 4. This diagram shows a straight line PQ with equation 3y minus s equal to 12. Point R lies on the PQ such that the ratio of PR to RQ is 3:1. Find the coordinates of R. Before we get the coordinates of R, we need to determine the coordinates of P and Q. These 2 points are on the straight line 3y minus s equal to 12. P is the y-intercept, means that if x value equal to 0, then y is equal to 4. So the coordinates of P is equal to 0 and 4. Whereas for Q, it is s-intercept, means y equal to 0. When y equals to 0, the s value is -12. Therefore, the s coordinate is -12 and 0. Now we can use the formula to find R. In order for you to have the better look, I redraw the diagram. Since the questions tell us the ratio of PR to RQ is 3:1, therefore QR is equal to 1, RP is equal to 3. Now we can use this formula to find the R coordinates. We let N be 1, M be 3. The coordinates of P be S1, Y1. The coordinates of Q be S2, Y2. So, 1 multiplied with 0, I have my S coordinates. Then plus 3 multiplied with -12. Then divided by N plus 1, that is 1 plus 3. We repeat the same step for y coordinates. 1 multiplied with 4 plus 3 multiplied with 0 here. Then divided by 1 plus 3. And we get the coordinates of R be -9 and 1. Now we look at the part B. The equation of the straight line that passes through R and is perpendicular to PQ. That is this blue line here. The equation of PQ is given in the question, that is 3y minus s equal to 12. We rearrange this to y equal to ms plus c form, and we have the m of PQ is equal to 1/3. Since the two lines are perpendicular to each other, therefore m1 multiplied with n2 is equal to -1. The gradient of the perpendicular line is equal to -3. Since we know that the gradient of the perpendicular line is -3 and the r is -9 and 1, we can substitute it into the following equation. And expand it, rearrange, we get y equal to -3s minus 26. This is the equation of the straight line that passes through the R and is perpendicular to R PQ. Example 5 is a long question with part A, B, and C. Let us look at the part A first. In the diagram, point P is -6 and 4, and point Q is 5 and 1. The extension of the straight line PO intersects perpendicularly with the straight line passing through Q at the point R, where O is the origin. A. Find the equation of the straight line PO. To form the equations y equal to ms plus c, we need to know the gradient and also the y-intercepts. Since this line PR passes through the origin, therefore its y-intercept is equal to 0. So what we need to do is to find only the gradient. To find the gradient of the line PO, we use the gradient formula. That is y minus y1 divided by s minus s1. So 4 subtract 0 divided by negative subtract 0, we get -2/3. The equation of the line PO is equal to -2/3x. Now let us look at the part B. Find the coordinates of the intersection point R. Coordinate of point R is the intersection of the line PR and QR. We need to know the equation of the both lines. From the previous part A, we know already the equation is -2/3x. So what we need to find now is the equation of the QR. Since we know that these two lines is perpendicular to each other, therefore we can apply M1 multiplied with M2 equal to -1. So M1 is -2/3, M2 will be equal to 3/2. So the gradient of the line QR is equal to 3/2. Now we let the coordinates of Q be S1, Y1. Then we use this formula, we use this equation, substitute in the values accordingly. M equal to 3/2, S1. S value of Q is 5. And Y value is 1. Okay, rearrange this. We get Y equal to 3/2S minus 13/2. This is the equation of the line QR. We let y equal to -2/3x be the equation 1. Y equal to 3/2s minus 13/2 be equation 2. We substitute equation 1 into equation 2. And group the right term s together. We have 13/6s equal to 13/2. Then we solve it, we get x equal to 3. When s equal to 3, substitute into the equation of QR, solve it, we get y equal to -2. With this, I know that my r is equal to 3 and -2. Now we solve for part C. The extension of the straight line QR intersect with the y-axis at t. Find the ratio of QR to RT. So here comes in this formula again. We let QR be n, RT be n. We have to find the point T first, that is y-intercept. So when s equal to 0, substitute into the equation of QR, we get the y-intercept equal to -13/2. So the t is equal to 0, -13/2. We let the q coordinate be s1, y1. The t coordinate is s2, y2. So substitute in the values accordingly into the formula. N multiply with the 5 plus m multiplied with 0 divided by n plus n. N multiplied with 1 plus n multiplied with the negative 13 over 2 divided by n plus n. Then we equal the x with x. That is 3 equal to 5n over n plus n. Cross multiply it, we'll get 5n equal to 3 bracket n plus n. Then we get 5n equal to 3n plus 3n. Simplify it, we have 3n equal to 2n. We write this one to m to n. And the ratio of QR to RT is equal to 2 to 3. Example 6. In this diagram, point M internally divides a line segment joining the points L and N in the ratio 2 to 3. Find the coordinates of the point M. We let N be H and K. I redraw the diagram as following. Since the question tells us the point M internally divides a line segment L and N in the ratio of 2 to 3, therefore Ln is equal to 2, Mn is equal to 3. Here we have to use this formula again. So I let N be S and Y, L be S1, Y1, N be S2, Y2. Then I substitute in the values accordingly to the formula. Then I try to simplify to solve it. I get this step. Then I will equate the x. That is negative 12 plus 2h divided by 5 equal to 0. Okay, we solve this one. Then we get that h is equal to 6. Similarly, we equate the y coordinate. That is 15 plus 2k divided by 5 equal to 1. Then we cross multiply it. We get 15 plus 2k equal to 5. We solve for k. We get k equal to negative 5. Therefore, the n coordinate is 6 and negative 5. Now we solve for part B. Part B. Find the equation of the straight line that is perpendicular to the straight line LN and passes to the point N. It refers to this blue line. So, first we have to find the gradient of LN. Given the L coordinate is negative 4 and 5, the n is 6 and negative 5, so we use the gradient formula to find the gradient. That is, negative 5 subtract negative 5 divided by 6 subtract negative 4, that's equal to negative 1. Since these two lines are perpendicular to each other, therefore, n1 multiply n2 equal to negative 1 can be used here. Okay, so we know that the gradient of the perpendicular line is equal to 1. Then we can form equation now. We can substitute the values of m and x, y into these equations. Substitute m equal to 1. Then the x values of n and the y values of n. Expand the right hand side and try to simplify it, we get this. Rewrite this one in the y equal to ms plus c form. We get y equal to s minus 11. This is the equation of the straight line that is perpendicular to the straight line LN and passes to the point A. Example 7 is a long question too, that consists of part A, B, and C. Let's solve A together now. This diagram shows a trapezium ABCD. The line DA is perpendicular to the line AB, which intersects the y-intercept at the point E. It's given that the equation of DA is y equal to 2x plus 11. And the equation of AB is y minus kx equal to 6. A. Find the values of k. Since the questions tell us the line AD is perpendicular to the line AB, therefore, the concept of m1 multiplied with m2 is equal to -1 can be applied here. That is, the gradient of AD multiplied the gradient of AB equal to -1. The gradient of AD is equal to 2. And the gradient of AB, we have to solve the equation first. We have to rearrange it in the form of y equal to ms plus c. That is, by shifting the negative kx to the right hand side, I get y equal to kx plus 6. Therefore, the gradient of my AB is equal to k. 2k equal to -1. So my k is equal to -1 over 2. Let's continue to solve for A2. To find the coordinates of A. A is the intersection of the line AD and AB. So, we let y equal to 2x plus 11 be the first equation, y equal to -1 over 2x plus 6 be the second equation. We have to eliminate either x or y. In this example, I will eliminate x. To eliminate x, I will multiply my equation 2 by 4. Then I get 4y equal to -2x plus 24. I'll name this as my third equation. Now look at the first equation and the third equations. I will eliminate my x by adding the equation 3 to equation 1. 4y plus y equal to 5y. 24 plus 11 equal to 35. -2x plus 2x, we get 0. So I have 5y equal to 35. So for y, I get 7. Substitute y equal to 7 into the equation 1. I get y equal to 2x plus 11. Shift the 11 to the left hand side. I get 2x equal to -4. So for s, I get my s equal to -2. My a is equal to -2 and 7. Let's continue to solve for part B. Given the ratio AE to EB is 1 to 2, find the coordinates of B. From the questions, we know that AE to EB is 1 to 2. Therefore, AE here is 1, EB here is 2. I redraw the diagram. Then, the coordinate of A we know already. We found in the previous part, that is -2 and 7. The coordinate of E, we can find it too from the equation y equal to -1 over 2x plus 6. This is C, means your y-intercept. Therefore, E is equal to 0 and 6. I let B be x and y. Then again, for this example, we need to use the ratio formula. We solve for x first. 1 multiply with x. Then plus 2 multiply with -2. Divided by 1 plus 2. So for it, I get x equal to 4. Similarly, do this for y. 6 equal to 1 multiplied with y plus 2 multiplied with 7 divided by 1 plus 2. So for it, I get my y equal to 4. Therefore, my B coordinate is 4 and 4. B2. Given the ratio of AE to EB is 1 to 2, find the equation of the straight line BC. From this diagram, we know that BC is parallel to AD. That means the gradient of BC must be equal to the gradient of AD. That is equal to 2. And we also know the coordinate of B is 4 and 4, so we can substitute it into the equations. And we solve for it, we get y equal to 2x plus 4. This is the equation of the straight line BC. Let's go to the last part, C. A point P, SY moves such that 2PA equal to PB. Find the equation of the locus of P. So, P moves tells us that it is a moving point. So we let P be S and Y. And 2PA equal to PB. So we use distance formula here. Substitute the coordinate of A, that is S value of -2 and Y values of 7 into the formula here. To the right hand side, we'll do the same things. We substitute the coordinates of B, that is S value of 4 and Y values of 4 into the formula. Then we square both sides to eliminate the square root. We square the 2, we get 4. Expand this, S plus 2, we get S squared plus 4S plus 4. We expand Y minus 7, we get Y squared plus 14Y plus 49. And to the right hand side, expand the S minus 4, we get this. Y minus 4, we get this. So, multiply in 4 for each term. And now move all the terms to the left hand side. And simplify your equation, you will get 3s squared plus 3y squared plus 24s minus 48y plus 180 equal to 0. But this is not in the simplest form. You have to divide each term by 3. Then you get s squared plus y squared plus x minus 16y plus 60 equal to 0. Then this is your equation of the locus of P. This diagram shows a rhombus MNOP. A. Find the values of T and the equation of NP in the intercept form. The word rhombus gives us one very important information, that is, the midpoint of ON is equal to the midpoint of NP. This is the property of rhombus. So, we find the midpoint of ON first. The midpoint of ON is 7 plus 0 divided by 2 and 14 plus 0 divided by 2. That is equal to 7 over 2 and 7. Next, we find the midpoint of NP. For the midpoint of NP, we add the edge of point N with the edge of point P and then divide by 2. That is 2 plus 2t divided by 2. As for y values, we do the same things. That is 4t plus 4 divided by 2. Since the midpoint of ON is equal to the midpoint of NP, therefore, we can equate that. We equate the edge. 7 over 2 is equal to 2 plus 2t divided by 2. 7 equal to 2 plus 2t, we get the t equal to 5 over 2. We know the t is equal to 5 over 2, we can get the coordinates of n and p. When t is 5 over 2, 4t is equal to 10. So the coordinate of n is 2 and 10. Substitute 5 over 2 into 2t. We get 2t is equal to 5. Therefore, the coordinates of P is equal to 5 and 4. Let us continue. From the previous slide, when t equal to 5 over 2, we get the n coordinate and p coordinate. With this information, we can form equation of np by using this y minus y1 equal to m bracket s minus sy. There are 2 points, n and p, so we can choose either one. In this example, I will choose n point. I substitute s equal to 2 and y equal to 10 into this equation. However, m is not given, so we need to calculate the gradient of this line by using the gradient formula, that is 10 minus 4 divided by 2 minus 5. Use your calculator, you get your gradient is equal to negative 2. Rearrange this into the y equal to ms plus c form, that is y equal to negative 2s plus 14. However, the questions want the np to be written in the intercept form. Therefore, we have to divide each term by 14, then to write it in the intercept form, that is s over 7 plus y over 14 is equal to 1. We solve part B now. NB is extended to QP such that the point P divides the NQ in the ratio of 4 to 3. So, we want to find the coordinates of point Q. We let the point Q be H and K. Here we use the ratio formula, and coordinates of N be your X1 and Y1. Substitute the values into the equation. 6 plus 4h equal to 35 and 30 plus 4k is equal to 28. So for h, you get h is equal to 29 over 4 and k is equal to negative 1 over 2. Therefore, the coordinate of q is 29 over 4 and negative 1 over 2. Example 9. This diagram shows the location of house A and house B drawn on a Cartesian plane. CD is a straight bridge such that the distance from house A and house B to any point on the bridge is always equal. Find the equation of CD. We'll let P be any point on CD. The coordinate of A, B, negative 3 and 2. The coordinate B, 5 and negative 2. Since the question says the distance from house A and house B to any point on the bridge is equal, therefore we have PA is equal to PB. Then we can use the distance formula to find both the distance of PA and PB. We substitute the coordinate of A into here, negative 3 and 2, and the coordinate of B, that is 5 and negative 2, into the formula. Then we square both sides to get rid of the square root. We solve it patiently and carefully. Then we get final answer is y equal to 2s minus 2. This is the equation of CD. We proceed to part B. B. A straight rod EF with the equation y equal to negative 3x plus 8 will be built. A lamp post will be installed at the intersection of the bridge and the road. Find the coordinates of the lamp post. We let y equal to 2x minus 2 be equation 1. Y equal to negative 3x plus 8 equal to equation 2. Then we equate equation 1 with equation 2. 2x minus 2 equal to negative 3x plus 8. Solve for x. X is equal to 2. Substitute x equal to 2 into equation 1. You get y equal to 2. The coordinate or lamppost is 2 and 2.
Let's try some questions for this topic by using the QR code or link shown on the screen. You can check your answer with your teachers.